A founder I was talking to asked me a question not long ago. He said, how do you stop AI from hallucinating? And I gave him my honest take, and that's you don't. You can't stop it from hallucinating just by the very nature of what it is. And when I said that, he looked at me like I just told him that the whole thing was broken. But then I told him the people shipping real software with AI right now are not winning because they found a model that doesn't hallucinate. They're winning because they built an engineering judgment process around the model. They put guardrails in place. They design systems that catch the mistakes before mistakes ship. They understand what they're producing deeply. And that's what this video is about. By the time you finish watching, you'll understand exactly how a single engineer runs a team of AI agents and the one thing that separates production-grade AI output from shipping junk. So let's get into it. I run an AI native software engineering firm called Vertice Labs. And when people ask me how we move as fast as we do, how we deliver in weeks, what most dev shops take months to build without all the issues, I tell them we built a delivery motion from the ground up, borrowing from mature software development methodologies like Agile and ShapeUp. We don't think about our team the way most companies think about development. The traditional model is you hire developers, project managers, QA, and each person has a specialty role. And then each person has capacity limits. If you need to ship faster, you just hire more people. And that model scales linearly. More output requires more headcount, and more headcount is slow to hire, slow to ramp, and it's expensive. The model we operate on is different. We have one staff engineer on a project and a team of AI agents. That engineer sets the direction, he defines the architecture, and he makes judgment calls. The agents do the heavy lifting, the writing the code, running the test, proposing solutions. The engineer reviews, steers, and decides. This is how every engineer at Vertice Labs works by default. So when you work with us, you're not getting a clever workflow that lives in one person's head. You're getting a team that delivers at a fundamentally different pace because the underlying model is different. There's much less coordination overhead, no waiting on people to pass work down the line, and that's how we're built. Here's how I actually think about what AI is. It's a layer of abstraction, and that's it. In business, a layer of abstraction is a lever. It lets you do more with less. Think about what spreadsheets did for finance. Before spreadsheets, financial modeling meant a room full of analysts doing calculations by hand. The spreadsheet compressed that work. One person could do what used to take 10. Think about what email did for communications, what cloud software did for operations, what accounting platforms did for bookkeeping. Each one was a new layer. Each one let a smaller team do what used to require a much larger one. Technology shifts follow this pattern. The people who learn to use the new layer well get dramatically more leverage. The ones who don't fall behind. AI is the same pattern, applied to software development. And most importantly, it doesn't mean that the thinking disappears. The strategy still matters. The domain knowledge still matters. Someone still has to understand the business well enough to know whether the output is actually right. But AI compresses the execution. It lets one engineer do what used to take a team. And the engineers who master it don't get replaced by it. They become the ones who leverage it. So what's the real engineering work when you're operating this way? Here's how I describe it, and it's not much different than it used to be. It's shortening the gap between the deep understanding of a technology solution and working software in production. That gap is where most software projects die. The idea is clear in the room, everyone nods, the scope document gets written, and then the thing that gets built 6 months later is not the thing anyone was talking about. The real engineering work is keeping those two things close together, making sure that when a decision is made in a conversation, it shows up in the product accurately and fast, and the cascading effects are thought through and handled. AI accelerates the execution of that, but it does nothing for the alignment side unless you're deliberate about it. That's why I spend a lot of time up front of every project on clarity. Our engineers spend a lot of time planning. What is the actual goal? What does done look like? What are the constraints? Not so we can hand it to the agent and forget about it, but so we can evaluate the output when it comes back, so we can test it, so we own that outcome. The judgment layer is the engineering. The agent does the lifting, the engineer does the thinking. So here's a concrete example of what this looks like on a real client project. We're building a point of sale system for one of our clients. We hit a point where a major change needed to be made to the core of the system. The kind of change that if you scoped it out by hand, you say it takes 2 weeks to build at a minimum. But Chris Jarvis, our VP of engineering, sat down with Fable, Anthropic's newest and most capable model, and he described the change in full detail, gave the model all the context that it needed on the system and the business, and he let it run. It took about 3 hours, but the change was implemented. It cost several $100s in tokens to get there, but the cost context compared to 2 weeks of staff engineer's salary is negligible. We had a conversation with the client that morning. They described what they needed, and by that afternoon, Jarvis had completed a change that would have taken 2 weeks of engineering time to implement, tested, and working. So we went from conversation to implement a feature in under 24 hours. And that's not someone that's just generating code and hoping it works. That's a highly skilled engineer who knows the system deeply enough to evaluate what the model outputs, direct it when it drifts, and close the gap when it doesn't quite fit. The model did the heavy lifting while Jarvis provided that judgment and that context and that guidance. And that's the collaboration that exists throughout our entire delivery model. So here's an example, a real world example of where this can go sideways. One of our engineers, Aram, who's working through a problem with an agent, he described what the issue was, gave it that context, and then the agent gave him some direction. So he kept going, and the agent kept validating. You're on the right track, that approach makes sense, good progress, etc. 3 hours in, Aram hit a wall. It was a big problem. And when he traced it all the way back, he realized that the agent had walked him down the wrong path from the beginning. And it wasn't lying, wasn't being malicious, it wasn't even hallucinating. It just didn't know what it didn't know. And so it kept confidently confirming a bad direction because Aram just kept asking it. And this is the hallucination problem in practice. It's not random nonsense, it's confident, plausible but it's wrong. And the only thing that catches it is domain knowledge and an experienced engineer. Aram knew enough about the system to recognize when it felt off. And without that, he might have kept going for another 3 hours or a week building the wrong thing. So the agent isn't the safety net. It's the engineer running the agent. And that's why engineering judgment matters. And that's why the domain expertise and context matters. The model is the tool. The judgment is what keeps the project from going sideways. So I want to talk a little bit about how you built that safety net into the system, right? Start with how I think about running my engineering team. I run a small, highly specialized group of engineers. Each one owns a specific area of a build. Each one is accountable for what ships out of their lane. But within each engineer's workflow, there's a second layer of structure. And that's how they run their agents. Think about a well-designed department within an organization. You have a manager who sets the direction and coordinates the work. You have specialists who execute those tasks. And you have reviewers who check the output before it ships. My engineers apply the same structure to their agents. An orchestrator agent at the top, its job is to understand the goal and break it down into tasks and delegate. Task agents handling the execution below it, one focused on writing the code, one on testing, one on integrations with other systems, and evaluator agents that sit completely outside of that build process. And its only job is to review the output and flag problems before they move forward. The engineer oversees all of it. They set the direction for the orchestrator, they review what the evaluator flags, and make a final call. So agents don't run themselves. Our engineers run the agents. That structure doesn't eliminate hallucination, it just catches any issues before they compound. So a week going down the wrong path becomes 3 hours because the evaluator flags it and the engineer course corrects. That's the system. Most of you watching this aren't writing the code. You're the CEO, the president, the CTO. You're the one responsible for whether the product ships, whether it scales, whether it integrates with your existing systems, and whether it actually works the way it's supposed to. So the takeaway is this: the risk with AI-built software isn't that AI is bad. The risk is that most development shops are using it without the structure I just walked you through. No orchestrator, no evaluator, no feedback loops, just a developer running a model, generating code, and shipping it. That approach worked for demos. It doesn't work for production systems that need to run at scale and integrate with your infrastructure and handle real business logic. So when you're evaluating a development partner, ask them what their process looks like for catching what AI gets wrong. Look for a specific answer, not a vague answer. Something specific about how they evaluate the output, who owns what. If they can't answer that clearly, the risk lands on you. Because at some point, and this is a matter of if, not when, the model will go down the wrong path. It's going to build the wrong thing. The only question is whether you will find out in 15 minutes or in 6 months into the build. So the companies getting complex software built right now with AI have teams running a system, not just a model. That's the difference it's worth paying for. This is the model that Vertice Labs is built on. Fewer people, production grade output, fast. Not because we have access to better models than anyone else, we have the same tools as everyone else, but because we built an engineering process around those models. We've evaluated how delivery has changed with the new capabilities. When we take on a project, we're not just prompting a model and hoping that the code works. We're deeply understanding what the goal is and what we're trying to produce. We're running orchestrator agents and task agents. We have evaluator agents reviewing output. We have automated quality checks built in before anything ships. And so our engineers are running all of this. They understand the client's domain well enough to catch anything that an agent might miss. And that's what production grade looks like. It's not a solo developer running a chat window and iterating. It's a system designed with the same intentionality you'd bring to designing a team. The result, we can ship what a 10-person team would ship with a fraction of the overhead. So we have faster timelines, a fixed fee model, and code that works. And when something goes sideways, we have the structure to catch it before it becomes a problem for our clients. The engineering judgment is the unlock. The model is just the tool. We've been building this way for a while now and it works. So here's what I'll leave you. Judgment beats the model every time. The teams shipping real software with AI right now are not the ones who found a model or the best model. They're the ones who figured out how to build the right structure around that. Orchestration, evaluation, quality controls, domain knowledge, expertise, that's the stack that matters. So if you're a CEO or president or CTO and you have a complex software product you need built, whether that's a first build, a stalled project, or something a prior dev shop couldn't deliver, this is the model we use at Vertice Labs. We work with operators and executives who know what they need to build and they need to find a team that they can trust to build it right. So head to verticelabs.io, take a look at what we build and who we build it for. If it's a fit, there's a way to get in touch. We move as fast as you can make decisions. So when you're ready, we'll be here.